Welcome everyone, my name is Jean and I'm super excited about today's webinar. It's combining Neo4j GDS and powerful graph visualization and analytics to uncover new insights. So let's get started. First, I would like to introduce today's speaker, Bernard. Bernard, maybe you can say a quick word about yourself.
Hello everyone, I'm Bernard Siman, PhD and software engineer in computer science. I'm working as a solutions engineer at Linkurious since 1 year now, and I will be showing you today how to leverage your graph exploration in Linkurious Enterprise by using Graph Data Science library from Neo4j.
And as for myself, my name is Jean, and I'm a managing director at Linkurious. So let's get started. First, maybe a quick word of intro about Linkurious. The company was founded in 2013. We have right now 2 offices, one in France, near Paris, and another one in the US. We are a team of 50 plus employees, and we are serving some 40 plus, 4,000 plus analysts worldwide, while using our flagship product, Linkurious Enterprise, to conduct investigations. So that's Linkurious in a nutshell. We are working with some partners such as Neo4j, and today we'll talk a lot about Neo4j, but we also have partnerships with Microsoft, Deloitte, DataIQ, PwC, and Capgemini. Right now we have 100 plus clients throughout the world, including Zurich Insurance, a leading insurance company, His Majesty's Revenues and Customs, Pioneer, Dun & Bradstreet, Ria Money Transfer, or Airbus. Let me talk a little bit about today's agenda. First, we'll start with a quick intro to Neo4j GDS, Neo4j Graph Data Science. Next up, we'll talk about how Neo4j GDS and Linkurious Enterprise can be combined and to what effect. Afterwards, we'll talk a little bit about concrete architecture examples of that integration, what combining Neo4j GDS and Linkurious Enterprise looks like in practice. And then, and I guess that's really the meat of today's webinar, we'll do a demo and Bernard will showcase how combining Neo4j GDS and Linkurious Enterprise can be used to detect fraud networks. So that's it for today's agenda, and without further ado, let's get started. So first, what is Neo4j Graph Data Science? Maybe you've heard of the product, or maybe not. So I would like to say a few words about Neo4j GDS. So Neo4j GDS is a library. It's a plugin for the Neo4j Graph database, and it adds powerful graph analytics and machine learning capabilities to Neo4j. Neo4j GDS integrates 100% with the Neo4j Graph database, and it adds some 65 plus pre-tuned graph algorithms and machine learning models that are all directly available via the Neo4j browser or via the Linkurious Enterprise UI. All of that in a very simple environment. And finally, Neo4j GDS is available both on-premise or in the cloud, depending on what you favors. So that's it, ready for Neo4j Graph Data Science or Neo4j GDS. So I mentioned some 65 plus algorithms. So now let's talk a little bit more about that. Really, these algorithms can be classified in broad categories, I would say, and there are 6 of them mostly. So first, there are the pathfinding algorithms, and they can help answer questions such as, is my client directly connected to a politically exposed person, for example? Next, we have the centrality algorithms, and that category can help answer questions such as, who is the leader of this group of persons? We also have community-related algorithms, and they can help you answer questions such as, is this moneylender acting alone or part of a larger network? You also have link prediction algorithms available in Neo4j GDS, and these algorithms can help you answer questions such as, are these 2 clients likely to know each other or not? You also have similarity algorithms, and it can help you figure out whether a criminal network with a particular structure is replicated, exists elsewhere. And finally, you also have embeddings which are more about turning the contextual data, the graph data, into machine learning friendly input. So these are, I would say, the 6 big categories of algorithms that are available in Neo4j GDS and the type of questions that they can help answer. Specifically, you can see the name of the various algorithms in each category. For example, in terms of pathfinding, there's the shortest path algorithm. In terms of centrality, there's the PageRank algorithm. In terms of community, you have the Louvain modality algorithm. And you can see, all the names of these various algorithms. Once again, all of these algorithms are available directly via the Neo4j browser for you to use. So I've talked a little bit about, GDS, what's inside that, the actual algorithms. But now I want to talk about why use Neo4j Graph Data Science in the first place. And there are 3 main reasons here. The first one is it's about going beyond Graph 101. So maybe you've been using the Neo4j Graph database, and it's perfect to store and query in real time a subpart of the graph data. But Neo4j is not designed to do advanced analytics on your whole graph. And that's where Neo4j GDS, advanced techniques, can help out. They can help reveal the role of entities in the graph, detect communities, and more, as we just saw with the previous slide. The second reason is that all of these advanced graph analytics are available with 0 headaches. There's no need to set up a complex architecture or hire a team of data engineers. Neo4j GDS can be installed in minutes. And finally, there are the use cases. And we have clients using Neo4j GDS for many use cases. We have clients using it for fraud detection, entity resolution, supply chain optimization, recommendation, and more. So these are, I would say, the 3 big reasons for using Neo4j GDS. So I just mentioned all the benefits, all the reasons for using Neo4j GDS. Now I would like to zoom in on, the value of combining Neo4j GDS with Linkurious Enterprise. And here there are really two big points that I would like to highlight. The first one, it's all about supercharging Linkurious Enterprise. Neo4j GDS can compute its scores. It can rank the importance of nodes or detect communities. And all of that, it can be used in Linkurious Enterprise to generate more relevant alerts, for example. And Bernard will show some examples of that. It can also be used to provide visual cues during the investigation process. Have nodes that are more or less big, depending on their importance, coloring nodes based on the community that they belong to, and more. So that's first big reason for combining Linkurious Enterprise and Neo4j GDS. And the second one is that it's really easy. If you're interested in advanced graph analytics and using Neo4j, there's nothing easier than Neo4j GDS. As I said, you can literally get started in minutes. And during the demos, Bernard will show how easy it is to then incorporate that in Linkurious Enterprise. So that's really why it makes sense to combine Neo4j GDS and Linkurious Enterprise. Now, Bernard, maybe you want to say a quick word about what doing that type of integration looks like.
Yeah, sure. So yeah, so some of you may be working in organizations that already have some existing tools helping you investigating fraud cases. So we can see in this diagram that the data science platform will be getting its data from existing know your customer databases, transactions, and other interesting information for your investigation. So once the data is available on your platform, you may use graph databases to apply some algorithms based on graph network analysis to enrich data science platform with those data, as well as the graph database. In parallel, you may already have a case management tool to follow the detected suspicious cases and to give human feedback to improve the data science platform. So Linkurious Enterprise provides easy-to-use APIs to integrate to such platforms. This leads to a smoother investigation journey and makes going from and to the graph component very easy. Linkurious Enterprise will help your investigators team explore this data in an easy way without any technical knowledge about Neo4j Graph Data Science library. And Linkurious Enterprise will read the data directly from Neo4j and makes it available for non-technical users. Okay, so now let's imagine you are new to data science and you want to start with a minimized platform that could be as performant as the one we described earlier. You can leverage the Graph Data Science library from Neo4j to detect suspicious cases and enrich your data. On the other hand, you can use Linkurious Enterprise to explore your graph data for non-technical users and leverage its case management feature to collaborate around the detected cases. And you can also refine your graph data science algorithm results by adding a human feedback directly from Linkurious Enterprise. So that's what you are going to see in the demo. First, I would like to remind you that you can send your questions in the chat and we'll be answering them at the end of the session or by email if we are short on time. So let's say we have a bank with an existing risk scoring engine. This bank is interested in investigating some information that can be found easier using graph databases. We'll be showing how graph data science can help detecting weak signals that can lead to hidden risky clients. Our data imported to Neo4j already contains a risk score. So as you can see here, this first person has a score of 0.3 in green, and another more risky person in red that has a score of 0.9. So the persons will have a score between 0 and 1, 1 being more risky. The steps I'll be performing during this demo to detect the community or generate a PageRank score should be performed after every ETL process. So whenever you add or modify data that might affect the final results, you will have to run the GDS algorithms again to take the changes into consideration. GDS algorithms are run on part of the graph. We call that a projected graph. A projected graph is a subset of the initial graph database that is projected into the memory for data science algorithms processing. I'm switching to Neo4j, and I'll start with my first query. So this query is adding a new node label for every node with a risk score higher than 0.9. This will allow a faster processing on a graph database side when searching for communities with risky clients. Since the label is only used for processing purposes, I will show you later how to hide it from Linkurious Enterprise visualizations using the schema feature. Step 2. So we'll add relations to people sharing personal information. The idea is to detect communities here of people having risky clients among them. A community is a group of nodes that have relations in common. In order to simplify our projected graph and make it faster, we have decided to add a relation between every two nodes that share a personal information. So here we can see it's an IP address, an email, an address, or a phone number. Once those relations are created, we can project a graph into our memory that will take into consideration the targeted nodes and the relations we have created. We will be analyzing an homogeneous graph. This means all the nodes are of the same nature. Here it's person nodes. So this is a projection query. So now we are creating in the memory a projected graph that is called communities graph. Finally, we launch the weakly connected components algorithm on the projected graph and write the found community identifier to our graph. So here we can precise that we are writing the community ID as a property named component ID. So those were the queries that we are running in Neo4j. Now to investigate every community, we would search for all the nodes with the same component ID. It means they belong to the same community. In order to limit the number of communities to be investigated, we only analyze the communities having among them a node with risky client label. So I have already configured an alert in Linkurious Enterprise. This is the query. So it's searching for the people that have the same component ID and having a risky client among them. And for sure, we're calculating some, we call them columns, that will give more insight for the investigator that is searching for a case to investigate. So I'll go into this alert. So as you can see, we have here the community ID, total number of clients, the normal ones, and risky ones. I'm going into a case. So you can see in this first case to investigate that we can find some people that were not considered as risky. The ones, for example, in orange here, or in yellow. Sharing personal information with risky people. So I can't find risky people here unless the styling. So here, the score is very high. That's why it is considered as risky. Let's go to another case. So here, for example, there's a risky person that has a score more than 0.9 connected to another person that is not risky at all. So we can see more the contrast in this example. And thanks to Neo4j GDS library, we can find the whole community in order to better investigate it. So that's the first example on how we can use the community detection from Graph Data Science and explore the risky communities in Linkurious Enterprise. We can also add comments. We can collaborate with our colleagues. So let's assign it to this colleague. And of course, we can confirm or dismiss a case. So this way, we can go back to those cases and make sure that we have all the confirmed or dismissed cases. I would like to mention here that some steps can be performed more efficiently using cipher graph projection. For instance, explicitly creating a relation between nodes sharing personal information can be replaced with cipher projection by creating this relation only in the memory graph in order to run, of course, the graph data science algorithms. For clarity reasons, in the next example, I will still show those steps to make the difference between all the relations I'm creating. So I promised you to show how to hide using the schema feature some categories. So here's the risky client label I added to my nodes. And as you see in the visualization, I couldn't see this label because I used here the schema feature where I can hide some labels or I can set them to view only or view and search. Let's go back to Neo4j now. I'll go to the second example. So here I'm going to show you a new way of using the GDS library to detect the hidden risky person of your database. We will be using for this example the PageRank algorithm that will find a relative risk score based on all connected nodes and the risk associated to those connections. PageRank algorithm is very well known to be used by Google to find an important web page that is referenced by many other pages. In fraud context, a person who is not sharing his personal information with others is more likely to be considered safe. This means his PageRank score would be smaller than fraudsters. On the other side, a person that is sharing personal information with other profiles is more likely to be considered as a synthetic identity. A person having most of his money transfers with a specific person can be suspected of money laundering. The page rank of such individuals would be higher because of the relations referencing them. In order to be more accurate, we estimate that some relations may have more or less impact on the final score. In the next example, we will be using a different influence weight for every type of relation between nodes. For instance, two persons sharing an email would have more influence than two persons sharing an IP address. Those influence weights can be easily tuned to fit your specific use case and the data available in your graph database. Now I will start by creating a relation between person nodes that are sharing personal information like phone numbers, emails, or addresses by running the following query. So the risk score used for personal information relations is the one belonging to person B. So this relation created here will have the risk score of person B and the direction to person A. I will next add relations using the same type of relation, which is relative risk, but with different score calculation for IP addresses sharing. We estimate that a shared IP address will have 10 times less impact on the total score since users don't have fixed IP addresses. So they may have the same address if they are trying to access from the same region or computer, but this is not like 100% sure. So I'm dividing the score by 10. Finally, I will add relations to illustrate the money transfers that happened between two persons through their bank accounts. So you can see in my query that I'm using the b.score twice when choosing the weight. The score will take into consideration the ratio of transfers that person A did to person B among all the transfers person A did. So here we calculated this ratio, and we are adding b.score to b.score again times the ratio. So this will give more weight to the relation. This query was already launched before we started this demo because it's a couple of minutes long. So I'm not gonna launch it right now. And I will go directly to the graph projection. So now that all the relations have been materialized with a single type of relationship, I will project my graph to keep only persons and the generated relations between them. Sorry for that. Okay. And now I can run the page ranking algorithm. Couldn't run it before for sure. So finally, I will run the PageRank algorithm and precise that the weight property can be used for score calculation. So here I choose the weight property that I have written in my relations, of course, projected it in my memory graph. And I will run the PageRank algorithm and finally write the PageRank score to this properties that I called PageRank. Perfect. So now that I have written the PageRank result to the nodes, we can create an alert in Linkurious Enterprise that will be generating cases to investigate. So this is the query. It's very simple. I'm taking the persons that have a score lower than 0.9 and the PageRank bigger than 2, instead of taking all the cases, of course. So we can define your own threshold and expanding some neighbor nodes, IP address, email, etc. I'm choosing A as a target of this alert because A is the main interest of our alert. So this is the person that has a big PageRank. And of course, I'm creating some columns to be more, to have more information when investigating a case. Okay. I'm running this again. Okay, sorry for that. I think I have already existing scores. So since it is we are using random scores, we may have had page ranks that are not enough high to get those cases. So here I have already created cases. I'm going into one of them. So once my case is investigated, so here, of course, I can expand this node. He has loans. I can expand the bank, for example, etc. I can make sure the address is close to the zone where his phone number belongs to. And once I investigated this person, I can tag him, for example, as suspicious. Let's say it's a risky person. So here I will choose a new score, let's say 0.9, and I'm tagging this person as suspicious. You can see that the color of this person changed. So this action will provide human feedback and will modify the results of the next run of the PageRank algorithm. We may also provide this feedback to external data science platform or database by calling the APIs that will update them with the latest investigation data. Thanks to custom actions feature, this can be done directly from your visualizations by right-clicking here on the person. You create a custom action for your specific API and call it. Other integration possibilities can help smooth the investigator's journey as well and allow them to gain precious time. So we have showed in this demo how the GDS library can be used along with Linkurious Enterprise to investigate hidden information in our data. We used for that two graph network analysis algorithms named weakly connected components and PageRank. This helped us finding persons belonging to risky communities, as well as highly connected persons sharing personal information and money with some individuals, which can be considered as a risky behavior. Since in the calculation we did, most of the money transfers were going for a specific person. I hope you enjoyed this demo, and I will give back the floor to Jean.
Thank you so much. So let's continue. Thank you for this demo. Just one more slide. I guess a bit of a recap. Why combining Linkurious Enterprise and Neo4j GDS makes sense. First, you can supercharge your investigations. Neo4j GDS can help enrich Linkurious Enterprise with more relevant alerts and visual cues. And I hope that Bernard's demo helps really see that in action. And the second point is that it's very easy to integrate. Neo4j GDS can be integrated in Linkurious Enterprise via the investigation UI. You can use the size, the color of the nodes, for example, to showcase their importance. It can also be embedded in query templates within the Linkurious Enterprise interface. For example, you can have a query template to display the community a given node belongs to, or even in alerts. And I guess Bernard showed a lot of that. For example, you can use GDS to detect potential fraudsters in a way that's just not possible with just Neo4j. So that's it, really, in terms of why combining Linkurious Enterprise and Neo4j GDS makes sense. Of course, we do have some time for questions. So let's get into it.